Hello and welcome to another Animation Notes tutorial. In this one we will use the amazing plugin Animation Notes to rotate a bunch of objects around their individual normals. This video is part of a series. If you haven't seen any of the other videos yet, maybe you want to check them out on my YouTube channel. Okay, let's get started! Okay, let's start and look at the problem. First, I create an icosphere, go into edit mode, select a couple of those faces, hit Ctrl I to invert, X and delete the other faces. So we're left with those. What I have here is in the overlays, I switched on the face normals. And that gives me those little green lines here, which shows me where the normals are pointing. To rotate around the normals, I have to go over here to transform orientations and select normal. And I also select individual origins. So now I can select, for example, these two, hit R and then C. And the C axis is now the normal of each of those triangles. So we're rotating. This is exactly what I want to do. But I want to animate this. And there is no way, or at least I don't know of a way to animate anything in edit mode. And I want to rotate each of those faces here, maybe at a different speed, somehow randomized. So if you know of any solution how to do this in Blender, please let me know in the comments. This, anyway, is an Animation Notes tutorial. I'm going to show you how to rotate individual objects around their individual normals. Now, before we start putting our Animation Notes loop together, there's one more thing that we need to understand. I'm going to create a plane and maybe in top view, move this vertex in a little and maybe this one also. Okay. Now I select all of them and rotate them so that the plane is rotated like this. Now I go into Animation Notes, create a new node tree, and disable auto execution for now. And the one thing that we have to understand before we can do anything is the node called direction to rotation. And that actually took me quite some time to figure out how this node works. It has all these buttons here, and then it has two vector inputs. And as soon as we have this put together, it is quite easy to understand what it does. It takes a vector, a direction, and it takes another vector, which is the guide vector, to calculate a rotation. Now, in edit mode here, and with the face normals enabled, quite short, let me make it 1 unit. So this is the normal of this face pointing this way. What we can do is we can use this node to rotate an object a certain way, defined by these two vectors. And what I've done before I started recording is I created this interesting object here, which is just the X, the Y, and the C axis. And each of these bars is 1 unit long. So what I can do here is I can take an object matrix output. I take my axis object and I rotate it using the output of the direction to rotation node. And now I still need to plug in things into this node here. So what do I want to do? I want to rotate my axis object so that the C axis points in the direction of the normal, so this way. And that's exactly what this means, C direction. Let me take a mesh object input. I use my plane, and over here I can enable the the polygon normals output so that I get this output here. the direction should be the normal. And then in order to calculate this rotation, we also have to give this node a guide vector. Now you can come up with some fancy calculation, like the x should always point in the direction of the furthest vertex on the x-axis or whatever. I just take the first vertex in this list here. Oh, I forgot to mention that the output here is always a list. So actually I want to get the first element from this list. This is the normal that I want to calculate. Now let's take the first vertex out of those four, one of them, and this is going to be our guide. But you have to normalize this vector. The normal vector is always of length 1. And this vertex location, of course, is not length 1. It is wherever the first vector in this list is, and then the length from the center, actually from the origin point to that vector. So I want to normalize this vector. I want to make it exactly length 1, and the vector math normalize node does that for me. I plug that into the guide, and what does that do now? If I hit T and then execute node tree, it does exactly what we wanted. The C-axis is now pointing in the normal direction of our face. Okay. And the X-axis, this one here, is pointing towards one of those vectors. So if I don't take the first vector in the list, if I take the second vector in the list and execute again, then the x-axis is pointing towards this vector. The y-axis is always perpendicular to these two. So we don't have to worry about this. We just need two axes to define the rotation that we want. Okay, let's go back to the first vector, execute. Now, knowing this and seeing what it does and seeing that it works, all we have to do now is basically we want to rotate our plane so that the C-axis, the normal, points straight up on the global C-axis. We need a matrix invert node, which gives us the inverted rotation. And if I use that and plug it in here, and you can see this thing, which doesn't look like anything. But actually, if I don't rotate my axis object, if I rotate the plane object and execute, you can see that our plane now is laying perfectly flat, and its normal is pointing straight up. And that's because we took the inverted matrix. Okay, now let's put things together and start animating. Let me simply delete all of this. We start with a monkey head, add one level of subdivisions, and apply that. Go into edit mode. Pick maybe this loop. That's not a good one. Maybe pick this loop, this one, and then hit C and do some circle select, like so. Maybe the back of the ears. Yeah, doesn't matter. This is just for demonstration purposes. And these are now the faces that we want to rotate. So I hit Control I, X, delete all those faces. Select all, hit Control E and select edge split. So now each polygon is its own thing, its own face. And I can select individual origins as the pivot point and S to scale all of them down a little. Okay, that looks good. Now still in edit mode, I hit P and separate by loose parts. So now each of these polygons is its own object. I go to object mode and move them to a new collection, which I call faces. So I can hide this here. And also still in object mode, I will select object set origin to geometry. Okay, that's the starting point that we need. And we can go right into animation nodes. Okay, first I have to get a collection info node. Take all those objects from faces, which gives me a list of objects. I'll create a new subprogram loop, add a new iterator object list, and invoke this loop and plug the object list in here. So now in my loop down here, I get each single object, which is just one plane, one face, or one polygon, and I can work with that. And what I basically have to do is 5 steps, 5 distinct and consecutive steps. The first step is I take the object and I move it towards the world center here. Once it's there, I will rotate it so that the normal points up, just like we saw before. Then I can rotate around the Z axis, which is the normal, and then rotate back and move back. Okay, first step, move towards the center. I'm going to use matrices. Matrix is a data type that contains the information for a location, rotation, and scale all in one thing. To get the matrix data of an object, I need the object matrix input. So now here I have location, rotation, and scale inside of this data type. And in order to move it, I need a matrix transform node. I need to transform this matrix. And where do I need to transform it to? Well, I need to transform its origin point towards the center. Where is the origin point? I need an object. I need a mesh object input for this object. And right here I get the polygon centers, which is exactly where we moved the origin to. First I need to get a list get element, because the output here is a list. Polygon centers is a list. I know I only have one polygon in one object, so I just get the first polygon center, which is this orange dot. And I need to compose a matrix for a location. I take the this polygon center is a vector going from the world origin to my object center. And to flip that around, to point the other way, I just take vector math multiply by -1, -1, -1. So now I have a vector pointing from here to here, and that's exactly where I need to move. So this is my first transformation. Move the object to the center. Next, I need to rotate the object just like we did before, so that the normal points up. Okay, rotation, direction to rotation. I need the vertex normal. No, I need the polygon normal, which doesn't show up here yet, but you can hit N and then you can enable the polygon normals output right here. So now we get the polygon normals. Okay. Again, this is a list, so polygon normals take the first element of the normals, and this is going to be our direction. Let me put this over here maybe. Now for the guide, just like before, Again, I take the first vertex, any one, I don't care which one. I have to vector math normalize this vector to length 1. Okay, this is going to be my guide. Remember, this points my x direction towards one of the vectors. This points my c direction towards the normal, and this gives me the rotation matrix that I would have to rotate in order to rotate it to where it is now. But I need the inverse rotation, so I need a matrix invert. Plug that in here, and that's the second thing we have to transform. So first we move it to the center. Now we rotate it so that C, the normal, is pointing up towards C. Now the third transformation can be our rotation on the C axis. Well, let's put that together. Matrix compose, we want a rotation. Okay, let's rotate randomly. So I just take a number random node. The seed is going to be the index of our loop. So we get a different number for each of the different objects. Min, I just set to -5 and max to +5. And I plug that into this rotation here, but this is a rotation, so I need to combine Euler. I want to rotate on the C, because that's now pointing straight up, and that's the normal. Use degrees, plug that in here. So now we rotate the object randomly on the C-axis, and now we have to move everything back. So we take another transform for the rotation, but not the inverted one, the one that we need to rotate in order to rotate it this way. So we rotate it back, and now we have to move it back. Another transform node. Where do we have to move? Well, here we moved down to the center with this negative vector here. So basically we want to move the location using the original vector that's pointing from the world origin towards here. Okay. So now we moved it back. I'm going to save this file quick, and now I have to actually do something with our transformation matrix that we put together here. Plug it into an object matrix output. Which object? Well, the one that we get in our loop. No more space here. So this object we want to transform with all of these rotations and transformations and translations. So now, whenever I hit execute node tree, all of these faces should rotate a little. Now let's see if that works. Oh yeah, we can see it rotates. Awesome. Well, let's look at those. Hey, they all rotate. Maybe a little faster, maybe a little slower. Ones are rotating to the left, the others are rotating to the right, and that's because of our random number -5 to maximum 5. But it works. We're rotating the faces. Now, one other thing that you might want to do is, let's say you have, I don't know, 100 faces now, and you all want to give them some thickness. You want to add a solidify modifier. Now that would be a pain in the butt now to do for all of these objects here. But of course we have animation nodes, and we can simply use animation nodes to do that. And a really easy way is to not have this loop output, 100 objects, or an object list with 100 objects in it, why don't we just take a mesh input, plug this in here, and then create a new list output over here, new generator output. And what we want to output is a mesh list. Okay, let me just move that over here. Here we have mesh list. So our loop subprogram has an output of mesh list now. And we can take a join mesh list to create one single mesh out of all of these polygons. And if I take a mesh object output node, plug that in here, create a new object called target, enable mesh. I can now hide my faces collection from viewport and rendering, hit execute, and everything is inside of one object target. And I can add a solidify modifier. Now they all have some thickness. What I also did was I added a bevel modifier. Okay, so now they have beveled edges. And still, every time I hit the execute node tree, still everything rotates a little. With every execution, we're filling this target mesh data with new polygons. And then the modifiers take care of the solidify and the bevel. Now, underneath, we can still add another Suzanne monkey head. Take our target, add another modifier, maybe a shrink wrap, put that on top. Target is Suzanne. We select target normal project and outside. Oops. Let me call this monkey. I selected the wrong shrink wrap target here. So monkey, okay. Let's bring the thickness out like this. Okay, they're still all on top of the other monkey head. And every time I hit execute, I get a rotation. Now I can go in here, enable auto execution for frame change, and when I hit play, we get rotating faces on the surface of our Suzanne. And the rest is just materials, lighting, shading, animation, rendering. You know how that works. And then we get a final result like this one. Now this looks cool because it's animated, but that whole effect with rotating individual objects on their normals can also be used for still images, like for example this one. It's only the random rotation that gives it a more natural, organic look. Alright, that's it for this one. Thank you for watching. Don't forget to comment and subscribe. See you next time. Bye bye.